Internet Protocol (IP) addresses. Every machine on the Internet has a unique identifying number, called an IP address. The IP stands for Internet Protocol, which is one of two protocols that computers use to communicate over the Internet. The other is Transmission Control Protocol, and the two are often referred to as one in the phrase TCP/IP. A protocol is the predefined way that someone who wants to use a service connects with that service. The someone could be a person, but more often it is a computer program like a web browser. A typical IP version 4, IPv4, address looks like this: 216.27.61.137. To make it easier for us humans to remember, IP addresses are normally expressed in decimal format as a dotted decimal number like the one above. But computers communicate in binary form. Look at the same IPv4 address in binary: 1101100001111.0011110. 1.10001001. Each sequence of numbers in an IPv4 address is called an octet because each has 8 positions when viewed in binary form. If you add all the positions together, you get 32 because IPv4 addresses are considered 32-bit numbers. Since each of the 8 positions can have 2 different states, 1 or 0, the total number of possible combinations per octet is 28 or 256. So, each octet can contain any value between 0 and 255. Combine the 4 octets and you get 232, or a possible 4,294,967,296 unique values. Out of the almost 4.3 billion possible combinations in IPv4 addresses, certain values are restricted from use as typical IP addresses. For example, the IP address 0.0.0.0 is reserved for machines on the local network, and the address 255.255.255.255 is used for broadcasts. Although 4.3 billion sounds like a lot of addresses, the Internet has grown so fast that a newer 128-bit address system was needed to replace IPv4. The experts at the Internet Engineering Task Force, IETF, began working on a new system in late 1998. IP version 6, IPv6, which officially launched on June 6, 2012, has room for 340 trillion 3 addresses, so we should have plenty of room for all our devices. For now. Just for the record, IPv5 was never formally adopted as a standard. As you might expect, IPv6 addresses look a little different from IPv4, which was created in the 1970s. Each segment in an IPv6 address uses 4 numbers and is separated by a colon. An example looks like this: BA5A972:4AA5:522E, B893:78DD, a 6C4F033. Because IPv6 uses hexadecimal notation, there are 16 individual digits that need to be represented. So besides the numbers 0 through 9, the letters AF have been drafted to stand in for the double-digit numbers. Sticking with IPv4 for the moment, octets serve a purpose other than simply separating the numbers. They are used to create classes of IP addresses that can be assigned to a particular business, government, or other entity based on size and need. The octets are split into 2 sections, network and host. The first octet is used to identify the network that a computer belongs to. Host, sometimes referred to as node, identifies the actual computer on the network. The last octet shows the host segment. There are 5 IP classes plus certain special addresses. You can learn more about IP classes at What is an IP address? Internet Protocol, Domain Name System. When the Internet was in its infancy, it consisted of a small number of computers hooked together with modems and telephone lines. You could only make connections by providing the IP address of the computer you wanted to establish a link with. For example, a typical IP address might be 216.27.22.162. This was fine when there were only a few hosts out there, but it became unwieldy as more and more systems came online. The first solution to the problem was a simple text file called a host table maintained by the Network Information Center, NIC, that mapped names to IP addresses. Soon this text file became so large it was too cumbersome to manage. In November 1983, Paul Mockapetris submitted 2 requests for comments to the International Network Working Group. RFC 882 outlines concepts of Domain Name System, DNS, which maps text names to IP addresses automatically. RFC 883 proposes ways of implementing the system. Thanks to his and many others' efforts, this way you only need to remember www.howstuffworks.com, for example, instead of the series of numbers and punctuation that is howstuffworks.com's IP address. URL, Uniform Resource Locator. When you use the web or send an email message, you use a domain name to do it. For example, the Uniform Resource Locator, URL, https://www.howstuffworks.com, contains the domain name howstuffworks.com. So does this email address, example@howstuffworks.com. Every time you use a domain name, the Internet's DNS servers translate the human-readable domain name into the machine-readable IP address. Check out how domain name servers work for more in-depth information on DNS. Top-level domain names, also called first-level domain names, include .com, .org, .net, .edu, and .gov. Within every top-level domain there is a huge list of second-level domains. For example, in the .com first-level domain there are How Stuff Works, Yahoo, Microsoft. Every name in the .com top-level domain must be unique. The leftmost section, like a www, is the host name. It specifies the name of a directory on a specific machine with a specific IP address in a domain. A given domain can, potentially, contain millions of host names as long as they are all unique within that domain. DNS servers accept requests from programs and other name servers to convert domain names into IP addresses. When a request comes in, the DNS server can do one of 4 things with it. 1. It can answer the request with an IP address because it already knows the IP address for the requested domain. 2. It can contact another DNS server and try to find the IP address for the name requested. It may have to do this multiple times. 3. It can say, I don't know the IP address for the domain you requested, but here's the IP address for a DNS server that knows more than I do. 4. It can return an error message because the requested domain name is invalid or does not exist.